No idea. Okay. But you had class yesterday, right? A lecture.
Yeah. Yes.
And how many people, more or less? No? You don't remember how
Last
many?
time I was watching online, so I don't know how.
Ah, okay, I see. Okay. So, right? Okay. So, welcome, and for all of you who are here and in your home or I don't know, and this is the seminar. In mathematical thinking, right? My name is Carlos Buitrago, and my email buitrago.okh@mipt.ru. Okay. So we need we created a group in Telegram. We are going to discuss every details on the course and the problem sets and many other things in this Telegram group. And then I will write to all of you, an email with all the details, okay? And so, we have two types of problem sets. So we have problem sets for class and for home, okay? So I'm going to try to resolve all the problem sets for class here, and the problem sets for home, you need to defend all these problems either with me or with the lecturer, okay? And I'm not sure about how are we going to, so the grade system of the course, I'm not sure about it, but we will explain to you later, okay? And that's it for these things. So, mathematical thinking. Well, this course is actually introduction to logic, okay? And yesterday you had, what did you study yesterday? So, something, no? Three tables, okay? So, yeah, the three tables. So you defined what is that statement? Yeah. So we have that we defined what a statement is. So and a statement can be either true or false, right? But not both. This is very important. So yeah, there are some statements in English, or I don't know, in any language that can be either true or false. We don't know that. We are not going to talk about them. We are going to talk about such statements which are either true or false. And then we let A and B be some statements, okay? And let, just for notation, 0 is false and 1 means true, okay? So if we have two statements, how many options do we have here? 4, right? 0, 0, 0, 1, 1, 0, and 1, 1. Yes? And then we can define relations between these statements. So, surely, so that we have A and B, we have A or B. We have A implies B, and so on. Okay, and you know this. You should know this from yesterday. Okay, that's good. So we're going to begin with our problems. Okay. So first of all, we will have a non-formal treatment of logic. Okay, this is not very formal. What we're going to do is not very formal. We are going to do it formally later, but not right now. Okay, so first, so split the following statements into. Okay, let's just write it. Split the following statements into connective and logical atoms. And then rewrite them using symbols. And write them using symbols. Okay, so first one, A. Roses are red. But violets are blue. Okay, this is the first one. What do we need to find here? We need to find statements, simple statements, or atoms. Okay, so an atom is the same that a simple statement. Okay, and so there are two kinds of statements: simple statements and compound statements. Okay, and so we need to find the simple statements here, and we need to find the connective, what is connecting them. Okay, so which are the atoms here, and what is the connective here? So roses are red. This is one statement. Okay, I don't know, A. Violets are blue. B. Just these are two different statements, and we have connective here, but. So so we have or, E, and, or, and implies, implication, but we don't have but. Actually, but is the same that and. Okay? So this is the same. Yes. So we have this. Now we have to write this using symbols. Okay, let's do it. So a rose. So roses are red. Okay? So what is X? X, imagine as the set of all the flowers. Okay? So we need to take a basic set. I don't know, basic set, let's call it omega. Okay? Every time we are going to change the meaning of this set. It depends on this. But here, for example, we can assume that X, that omega is the set of all the flowers. So we are saying that the flower that we have here, X, has this property, rose. Okay? This can be true or false. So this can be not a rose, it can be something. And that is red. And violet, so are blue. Okay, so in this case we used X, and now we are using Y, because these are different things, okay? And that's it. So that's all we have to do by now. It's very simple, okay? I repeat, this is a very not formal treatment of logic. We just, well, the lecturer wants you to understand deep what's the meaning of all these connective symbols, okay? So that's for A. Now B. If at least one row is not red, okay, if at least one row is not red, then it's not the case that violets are blue. Then it's not the case that violets are blue. Yes. So, if at least one the quantifiers. Did you study the quantifiers yesterday? I think you did not. You didn't have time. But OK, we have that two main quantifiers for all and exist. OK? You know this. That's it. So for all and exist. And in this case, if at least one row, so this if at least, so if there exists x, if there exists x such that rows is not red, so the rows how do you say is not red? So we said here is red. How do you say here is not red? No? So we here. Negation, yes. So right, it's not red. Okay? So if at least one row is not red, right? Then it's not the case that violets are blue. Then it's not the case. So violets, again, now X are blue. So here we can use X again, because when we state here X, there exists X, we use it just for this statement, okay? And then after that we can use X again. This is a different X, okay? And so we have it, but we still have to say this. It's not the case. What do we need to add to this sentence? Negation, yes. Okay? And that's it. So, as you can see, this is not very difficult by now. But anyway, we have more examples. C. Okay, can I? Yes, here? Okay. Okay, C. Neither roses are red, nor John likes them. Neither roses are red, nor John likes them. In this case, we have to add something new, right? Because we just have that something that has some property, right? That a flower that is a rose, or that is of a defined color, and now we have that John likes them. Okay. So how do we define this? We have to write, I don't know, likes, for example, likes. Here we have X and Y. Okay, so X likes Y. Okay, and then that's it. So neither roses are red nor John likes them. Okay, so likes John and Rose. Okay, and no, wait, one second. So roses are red. Okay, so this is the negation, neither roses are red, neither roses are red, nor, so and negation again, John likes them. John likes rose. Okay. Next, D. So if John likes roses and violets, then either Mary likes violets or John likes Mary. Okay, let's write it. If John likes, if John likes roses or violets, right? And violets, and then either Mary likes violets, then either Mary likes violets, or John likes Mary. So if John likes, so we have if, then. This is implication, right? So if John likes roses and violets, so likes, likes John rose. What else? So John likes roses and violets. So and likes John violets. So John likes roses and John likes violets. Okay. Then either Mary likes violets or John likes Mary. So we have here or, but this is not this one. This is not exactly this one, because it has to be one of them. Okay, so either or. Okay, it's a different one. So no, yeah. No, well, yeah. Well, no, in this case, yeah, it's either or. Yeah, it's the same. It's or. I was wrong. Okay, so likes. We have Mary likes violets, so Mary and violets, or John likes Mary. So again, likes John and Mary, and that's it. Okay, and so on. So we can construct really complicated sentences, and of course we are not 100% sure that this is correct because it can has many different interpretations in this case, but I think it is. Okay, and let me just write one more, and then we can begin with something more interesting. Okay. So E. The fact that roses are blue implies that Mary likes John only if John likes violets. The fact that roses are blue implies, right? Implies that Mary likes John only if John likes violets. So, implies, the first thing we can see, only if, yeah, and yeah, and this is enough. So, only if John likes violets. Let's write that. Likes and now this part. So only John's like that. Roses are blue. So roses are blue. This implies that Mary likes John. And that's it. Okay. So, any questions about it? I think it's pretty clear. Is it clear? Yeah. Okay.
Like John Violet.
Yes. From here, look. Yes. Okay. So, next exercise. We're finished with this one. So, second, let n be some natural number. You know what natural numbers are, right? Now, which of the following statements are true? Which of the following statements are true? So, A, if n is, so if n is divisible by 4, then n is divisible by 2 or by 3. When n is So is it true or false? Let's write it more clear, okay? So if n is divisible by, so if you can divide n into 4, let's just use this notation, okay? N can be divided into 4. Then n can be divided into 2, or n can be divided into 3. Right? Is it true or false? Why? Okay, it's true, yes. But why? So look, n can be divided into 4, and we have that n can be divided into 3. This is true, yes? So 1. And we have or here. So it doesn't matter what we have here. Yeah, and no, 1 means true. So if you can divide a number by 4, you can divide it by 2. Yeah. Yes. Yeah. Okay, you mean like any number, right? No, in this case, I mean this. So this is true. Yes. B. If n is divisible by 2 and by 3, so if n is divisible by 2 and n is divisible by 3, then n is divisible by 4. Is it true or false? Think about it. Should be true. What about n equals 6? So for n equals 6, it's not true. So in general, this is false. Yeah, but because of n equals 6. But if n, so for n, this is false. And for n different than 6, this is true. Okay? Right. Which one is the following? I think this one. This one? Yeah. So, any questions? No? I think it's pretty clear. Great. Now, if n is divisible by, so this is number ABC, and divided by 4, but n is not, it can be not divided by 2, then n equals 8. What about this one? This is a tricky one. So, is there any number that you can divide it by 4, but you cannot divide it by 2? Well, no, right? No, no. So this is false. But what happens when we have two statements, A, B, and the implication for these two statements. If we have, so we have 0, 0, 0, 1, 1, 0, and 1, 1. What do we get here? Yes. So, this is false. And in our case, it doesn't matter that is false. It's going to be true. So, it doesn't make sense, you know. But yeah, that's it. So this is false, yes. But the sentence itself, it's true, okay? Because of this. So you can see it here, right? So do not forget about these rules, about this rule. I would say that this is the most important rule here, okay? Because it's the only case in which we have 0, right? Great. D. This one is nice. So if n is either odd or even, so let me write that. If n is either odd or even, then n is greater than 3. So, if n is either odd or even, how do I write this using this notation? I listen to you. So, we need to use this notation here and construct a statement for which in which we say that n is either odd or even. It's neither right here. No, it's either, yes, odd or even. So, how do we write that n is even? Yes. Okay, so this is an even number, right? And now, or that's it. Okay, so if n is either odd or even, then n is greater than 3. Is this true or false? Always. So yeah, it's true for n at most 4, and false otherwise, okay? And that's it. Okay, is it clear, this part? Yes? Everyone? Okay. Now, okay, let me then this. No, that part. So look, this is not a lecture. This is a seminar. Do you know what a seminar is? What is the difference? No. Okay, that's a good that you say that. Look, in every country, in the universities, everything is so different. In Russia, well, here you have lectures for theory. So you sit and you listen. If you have any questions about theory, you ask, right? In the seminars, we have to resolve problems. And you have to ask questions, as many questions as you need, because you will have problems like this, a little more harder, I would say. But you will have to defend all this, and so if you have any questions, please do it. Okay, ask as many questions as you want. Well, if they are not long questions, because we don't have much time. But seminars, it's to resolve problems and to ask questions. Okay. If you have any question about theory, then you can ask to your lecturer. So next, number 3. What is a tautology? It's always true. Yes. And now formally, how would you say that it's always true? So let's write it down. I think yesterday you had yes. You had this yesterday. So a tautology, let me remember. So f of a1 and a_n is a tautology if f is true for all possible truth values of a1 and an. So this is the definition, but do you understand it? Yes? So is it clear? So what is this? F. This is a statement. A statement. We have a statement, a compounded statement of many other simple statements, a1 and an, like this one. Okay? So this is, for example, F. I don't know, a1 and a2. Okay? That's it. And if f for any value, so a1 and an can take values true or false, and if it doesn't matter what values are these statements taken. If it is always true, then this is called a tautology. That's it. So I think we can take a break for 3 minutes. Right. So, uh, we need to define which of the following statements are tautologies. Okay. A. A implies B, implies A, implies A. So, we want to prove that, what do we want to prove? So we have a statement here. And we know that, okay, again, so true for us will be 0 and 1, and false will be 0, okay? So what do we want to show here in this case? This statement, that this statement what? Is true or false. So we want to show that, we want to know, is it a tautology? So is this equal to 1 no matter what A and B are, right? But we have two ways to resolve this problem. Tell me the first one. Yes, that's the first one, the obvious one. So we have A, B. We write all the possible values. And then we write all this here. And we can find, and we need to show that this is 1. But this is not always a good idea because I mean, now we have, this is short, but this can be really long, you know? So let's prove it by contradiction. What does it mean? So let's assume what? Let's assume that this is false. And we have to come to a contradiction here. So this is, if this is false, if and only if, this is false, if and only if, what? Again, please, I just can't hear you.
The first one is true, and the second one is
Yes. So if this is true and this is false, so we have that A is 0, okay? And now this is true. If and only if, so let's write. No, if and only if not, but yes, if and only if. Is 1 and the A is 0. Yes? And this is true if and only if. Where do we get a contradiction here? Yes. So this is the proof. So we got a contradiction. So this cannot be equal to 0. So it is always equal to 1, so it is always true, so it is a tautology. Okay? Yeah, you got the true, yes. Yes, okay. Yeah, there are many ways you can find the contradiction. I mean, you will find it. That's for sure. Maybe there are long ways, there are short ways. It depends on you. Okay? The important thing is to do it correctly.
But if I like two and I want it
Okay, where?
I like two
Uh-huh.
I swap
And then A is 1, yes?
yeah I want that the first part is
The first part, you mean this part? Yeah, that is the contradiction. Yeah, yes. So look. So this is 0, but this has to be 1. Okay? So there are many ways to find the contradiction. There's not a unique way to find it. Okay? You will find it, that's for sure. Okay? The important thing is to find it. Okay, B. So A implies B, and this implies that A negation of B, and this implies the negation of A. Implies B. Yes. Again, the same thing. Let's assume, so proof. Let's assume that this is equal to 0. So this, all this. So let's do it that way. This is equal to 0. If and only if what? Mm-hmm. Yeah, so and then this, let's write it way, this is equal to 0. And this happens if and only if and B equals 0, right? And here what do we have? This is true if and only if this is 1. So if A implies B is 1 and negation of A is 0, so if A is 1 and then and this is true if and only if yeah. A1 and now base 0, so base 1 and so where is the contradiction? Yes. Contradiction. Okay. I think you got it, right? It's not complicated. But still, we have to resolve many problems, okay? Because, yeah, this is simple. I mean, the idea is very simple. But anyway, you can get really confused here. So we still have to resolve another problems, okay? Is it clear, everything? Okay. So we have A, B, C. This is an easy one. And I think you, no, it's another one, sorry. AC or, sorry. or let me check that. So AC or B C, A, B or C. Yes. So again, I want to hear you, everyone. Okay. Okay, yeah, so first of all, we want to show that this is 0. I mean 0, false, okay? Don't get confused here. It happens. Okay, this is 0. If this is 0, then what if this is 0? Yes?
The left part is 1, the right part is 1.
Which part? This part? This? Are you sure? Why?
If only if all the twos are false first. Left part false and the right part false.
Yes, why?
Because it's off.
Yeah. So we have two statements here. Pay attention to this, okay? And then this is possible if and only if this is false and false, right? Then, okay, next.
The left one is false. If only what's inside the brackets is true.
Is what? True? What do you mean true?
Like A implies C is true.
Ah, okay, yes. So if and this is true if and only if
A1, C0.
why not?
A1, C0.
Okay, we got the first one, and now this one. So so this should be if and only if and only if. So B is 1 and C is 0, right? Okay, and this if and only if A is 1 and B is and C. So this should be equal 0, right? This is 0 if this is 0 and 0. Well, not only 0 and 0. Yes, just yeah. So we got again the contradiction in what letter? What statement? Where is the contradiction here? D. And so on. Okay? So again, what is a tautology? Tautology. Yeah, speak. Okay, it's always true. Okay, let's set it up. Okay, great. Now, let's resolve the last one of this. These have to be really clear. So number D. So D is, just take it, right? D, A, and C. No book. So you have to ask to the lecturer, okay? But he doesn't use any book, I think. So he just. Where did you find the everything will be in the, I mean, where would you have to ask that to the lecturer? The lecturer. Yes. I mean, you have to imagine that. Sorry. All I'm doing here is that he asked to do, okay? He is the main professor here, okay? And this is the material he wanted you to learn today, okay? So, where was I? So then, C, D, A, or B. Somebody? Come on. Okay, please explain to everyone what do we have to do and how to do it. Wait a second. Okay, take this for 1 sec. Here. And this on your.
Okay. It's nice. It's good.
So put it for somewhere. Be careful.
Okay.
Now speak loud.
Okay, try. Here, what is this bracket?
Yeah.
Okay, here we.
I'm trying to find the right brackets. For example, this bracket is the closure of this bracket, and this one is the closure of this one. So that to this expression to be false, this part should be 1, and this part should be 0. Okay.
So this part you mean right down.
Yes.
Yes. Well, here, right here, 0 because.
Okay.
Okay.
So the first one is 0. C equal to 1 if only if B equal to 1 if one
So-
has to be 0, and this one can be either A and C can be either 0 or 1. Because the implication A, B, we have got 0, 1, 1, 0, 1, 0, 1, and then the other is 1, 1, 0, and 1. So that's, this one can be 2, is only 2 when this one A is 0 and B is 0 or 1, and when B is 1 and this one is 1. That's the conditions for that.
Okay. Okay, something is weird here. Okay, so next.
So if you take the first expression, E equal to 0, A equal to 0, so A and C to be have to be A or
So why don't you first do it for this slide?
Yeah, therefore it's fine. Will be much easier.
for that, this part is 0 only if not B is 1, and all the rest of the expression is so 1, and the other expression is C.
So C and D, which are equal to. So C is equal to. Okay, look, and okay, yeah. Okay, look,
Well, here we can get B equal to 0. Here A or it's only if we have A equal to 0, B equal to 0, and not C equal to 0, and that C equal to 1.
Okay, so by now everything works, right? We don't have any contradiction. So yeah, and this should be equal 1, and then D so should be equal. This should be equal what?
So this is something if we have got two cases, if B equal to
No, we have just one case. We know that D is equal 1, right?
let's take D equal 1. So
Yes.
D equal 1, and if D equal 1, so this one is 1. D, C equal 1, and A and C equal 1, that E equal to 1.
And now where's the contradiction? A, right? Yeah, that's it. So don't forget about.
Oh, shit.
Okay, great. So, a second. Then, that's it. It's clear, right? For example, in this case, yes, we have two different cases. Yes. So if we see that we have two different cases, we don't need to do all the possible cases. We just have to look at this case, at the second part of the statement, and then we can find, for example, in our case, we found D, and that's it. So we don't need to find all the cases for D either 1 or 0. Just we know from here that D is equal 1, okay? And that's it, and we got the contradiction. And I think everything is clear, right? Okay, great.
We found the contradiction before, like splitting the whole part and before the second part. Maybe we have some complicated part, and we found the contradiction before, like completing the whole thing. You understand?
Yeah, of course. I mean, you have to find the contradiction somewhere. Doesn't matter in which step. Okay, next. Here. Now, we already know what a tautology is, and that's it. Okay. Next. What is the meaning of this notation? equivalent to B, equivalent, not equal. And what does it mean? The two statements are equivalent.
Means that A implies B is true and the B implies A is true.
Well, this is a theorem, yes, yes, but this is not the definition. What is the definition? So yeah, so the
Equivalent only if both of them have got the same value.
Yes, they have the same truth value.
yes, so they have the same truth values for any truth values among them, okay, right? So they can be either, so in this case, that is why, one second, how do we need to write this? So if A, B is a tautology. So this is true if and only if this statement is a tautology. Why? What do you think is that? So this is a theorem. Well, that's not even a theorem, I think, but this is true. Why do you think it's true? So what does it mean that this is a tautology? So this, like you said, means that A implies B and B implies A, right? And so if A is true, then B is true. And in this way, it's so A is true if and only if B is true. And we can say also that A is false if and only if B is false. So it's the same, right? And now, why this is true? Yeah, you see it? Okay? So they get the same values for any truth values. Okay? So when he gets one, when B gets 1, A is true also. And when A is false, B is false. That is why this is true. Okay? Now we have 10 minutes. Now exercise number 4. Proof that that way. A or B. Okay. So we need to prove this. How do you propose to prove it? Yes. Yes. How? So tell me, what do I need to do? Okay, so look. We can, for example, use what I wrote here. Okay, so let's suppose that this is false. And let's also suppose that this is false. We should obtain what? The same values for A and B, right? Now, why am I supposing that they are false and not true? Because true also works. Why do you think?
Because it's easy to get
Yes, because we have only one option for implication when it's false. But when it's true, we have three options. So, right? No, A, B. Then 1, 1, 1 is 0. No, it's 0, 0 and 1. Okay? So we have three different options for A implies B. But we have just one option for false when it's false. So that's why we're going to do it this way. So what does it mean? So A is equals to and B, in this case, not A is equal to 0. So A is equals to 1 and B 0. That's it. We prove it. Okay? So, again, we have to prove that these two statements are equivalent. And we know this. So, we need to prove that when this is false and this is false, then the values of A and B are the same. Okay? And that's it. So, next. No. So this was A, now B. Mm-hmm. Yeah. Who wants? Come on. So you're going to do it fast, so you don't need to the microphone. Okay. I will explain it.
Okay, so I will start at the beginning. I think like here, this is gonna be for negation of this, and for this.
So you,
So, like this is gonna be, if we like assume that this is gonna be 0,
yes.
and this is also gonna be 0. So this will be like, we will have that A is 0 and B is 1.
Mm-hmm. So we have that this is 0, false, then A is 0, and B is 1, yes.
And this is
Also, when B is 0, then
what?
And 0 and 0 is 1? Yeah.
So this is also, this is 0 when we have too many cases. This will be 0 for many cases. I think.
Why?
Because this will be 0 when this one is 1.
Mm-hmm.
So we'll have 3 cases. I think that we will, if we assume.
But we already know.
Yeah.
Okay, wait, yes. Yes, so look.
I think for the right one, it's 0 even if B equals to 0.
B.
A 0, B 0, 0, A 0, B 1 is 0.
So wait a
Yes.
second.
I think you should just take the left part is 1 and the
Um,
right part is 1. Then
yes.
it becomes
Yes.
Mm-hmm. You're right.
So let's change it. This will be 1, and this also will be. This will be 0.
Yes.
And for this will be A will be 0, and B will be also sorry.
This is what?
No, this is
No, I
0.
think you usually take the left part because it's implication. When the negation of an expression is true, it means that the expression is false. So you can take just A implies B equal to false.
Yes, this is false.
This is false?
Yeah.
Are you sure?
No.
No. Sorry. Yes, this is how it will be false.
Uh-huh. And now we got
now
it.
they are done. Yes.
Yeah, now we're done. Yeah, okay, thank you. And so, is everything clear? I think it is, right? And we will have more exercises. We will send you an email with all the information. Do you have Telegram? All of you, that's great, of course. So all the information, so remember about this. We have two problem sets. The problem sets that I'm going to resolve here, and the one that you are going to resolve, and you have to defend, okay, to me, okay? And that's it. Thank you.